Lesson 38, Hypothesis Testing Procedure for Two Population Proportions. Example 2. Are men less likely than women to think that participating in an internet romance is cheating on their partner? Use the following sample data and a 5% level of significance to answer this question statistically. Now, there are two possible answers to this question. Either yes, men are less likely, or no, men are not less likely. So to answer this question statistically, we need to conduct a hypothesis test procedure in order to determine if this idea is valid or not. Now, the statistical form of the hypothesis can be taken from the question. Are men less likely than women? Now, likely is a likelihood or a probability, and probabilities are a form of a proportion. So here we're dealing with the proportion. The proportion of men, which is one proportion, and the proportion of women, which is a second proportion. So we have a two-proportion problem, and we want to know if the men are less likely than the women to think that participating in an internet romance is cheating on their partner. This would indicate a P1 less than P2, where the first proportion is the proportion of men, and the second proportion is the proportion of women. Now here we're going to use a 5% level of significance. So this hypothesis test will be conducted with alpha equals 0.05. So we'll be conducting a hypothesis testing procedure involving two population proportions. So the following steps are used to guide us through our hypothesis testing procedure, starting with stating the hypotheses statistically. Here we have our one answer, P1 less than P2. And if this is valid, the answer is yes, men are less likely than women to think that an internet romance is cheating on their partner. Or if the answer is no, the opposite would be valid, and P1 is greater than or equal to P2. Now, the greater than or equal includes the condition of equality, and the condition of equality is always labeled with the HO, and the opposite is labeled as H1. So this hypothesis test is dealing with an HO of P1 greater than or equal to P2 versus H1 that P1 is less than P2. Now we'll be using our customary alpha equals 0.05 and the 2prop-z-test command on the TI-84 calculator to calculate the p-value. But to do that, we need our sample data. A Harris Interactive poll asked a random sample of adults, do you think that participating in an internet romance is cheating on your partner? As a result, 86.9% of 283 men polled and 97.5% of 317 women polled thought that participating in an internet romance was cheating on their partner. So, when we find out that 86.9% of 283 men polled thought that participating in an internet romance was cheating on their partner, we know that the sample for the men, which was our first population, N1 equals 283. And that the first sample proportion, P1 hat, equals the 0.869 for the 86.9%. Now, the required input in the TI-84 calculator is the X1 and the N1, not the P1 hat. So we need to solve for X1 based on the given N1 and P1 hat. To do this, the data value X1 is calculated by taking the sample size N1 times the proportion P1 hat. In this case, 283 times the 0.869, which equals 245.927. But remember, the data value X is a count, which is discrete, so it needs to be a whole number. The reason for the 245.927 is because the sample proportion was rounded off, so it introduced some round-off error in our calculation. So rounding off this value to the nearest whole number, we find that the X1 actually equals 246. So here's our first sample results of the men. We're also told that 97.5% of 317 women polled thought that participating in an internet romance was cheating on their partner. So here, the 317 women polled is our second sample size, or N2 equals 317. And the 97.5% is our second sample proportion, or P2 hat. So P2 hat equals 0.975 decimal. Again, the input in the TI-84 calculator for this example needs to be the data value x2 and the sample size N2. So we can solve for the data value x2 by multiplying the sample size and the sample proportion. In this case, the N2 times the P2 hat equals 317 times 0.975, which equals 309.075. Again, the data value x is a count or whole number. So we round off the result here, x2, to 309. So now we have our second sample results. So these data values can now be used in the TI-84's 2-prop z-test command to calculate the p-value. To do this, we would press stat to do statistics, arrow over to tests, where our confidence interval hypothesis test commands are found, and arrow down to 2-prop z-test. Enter, and then enter the data. x1 equals 246. Enter. n1 equals 283. Enter. x2 equals 309. Enter. n2 equals 317. Enter. Now h1 contains the less than inequality, so I arrow over to less than, press enter to select, and then down arrow to calculate, where we press enter and it calculates the p-value. The p-value rounds off to 4.8 e minus 7. That is, the p-value was so small the calculator displayed it in scientific notation. And the e minus 7 indicates that the decimal point here between the 4 and the 8 really belongs 7 places in the negative or to the left. And then the leading values, blank values, are filled in with 0. Now, the p-value being a probability, we only need to round off to 3 places after the decimal. So this p-value rounds off to 0.000. Now that we have our p-value, we can reach our conclusion. Since the p-value of 0.000 is 0.05 or less, the decision is to reject HO. And when we reject HO, we have enough evidence to indicate that HO is not valid. And if HO is not valid, the opposite idea, H1, is the one that is valid. So the data supports the idea that P1 is less than P2. And since men were the first population and women were the second population, P1 less than P2 leads the conclusion that men are less likely than women. So, based on the results of our hypothesis testing procedure, we can reach the following conclusion. Therefore, at the 5% level of significance, men are less likely than women to think that participating in an internet romance is cheating on their partner.